I'm an agriculture engineer, and I started my professional career as an agricultural extensionist in West Africa, and from there on I worked in a lot of different fields in international development cooperation. And then typically what you see there is that all those projects, they go from health to water and sanitation to infrastructure to agriculture. Each of those projects, of course, they have their own information requirements. And also typically when let's say the political direction of a government, for instance, like ours, I'm from the Netherlands, when it changes, so some governments are more into small enterprise developments, other are more into environments or gender related projects. Also, every time the political orientation of a government changes, that also means that those projects, they have to report on different things. They have to report on their own, on different KPIs, etc. So that means that for all these projects that consume literally billions of euros or dollars, they will constantly have to deal with changing information requirements. So when I went, my first posting was in West Africa, in Mali, in 1983. And there were hardly any people, be it locals or expats, who had any idea about, let's say, a lot of experience in IT. So, and they didn't have any programming skills. So from that time onwards, I started to think more like, okay, we need to have modular systems that are very metadata driven, so that you can adapt them without having to write code. Mm-hmm. Now, fast forward, let's say 2013, 2014, I ended up in a project related to journalism. And as you will notice, I have a lot of background in non-commercial stuff, a lot of NGOs, government stuff. And when we were doing that journalism project, so basically you relate events to locations, to publications, to people, that was at the same time that there was this big news about the Panama Papers. That was 2014, 15. And so we started to look into the technology that they were using, because in terms of concepts, it was quite similar to what we are doing, although a couple of orders of magnitude bigger. And then we stumbled on graph databases. And that's basically was my, let's say, the first moment that I learned about graph databases. Although we had been doing stuff on top, like graphy stuff on top of relational databases, but that is, let's say, at a certain moment you will hit a brick wall. Mm-hmm. So, but then liking let's say the graph model, or basically the triple model, whether it's RDF or LPG, I liked it a lot. Me not being a developer, I was not able to build any applications on top of it. So that's where we started with Graphileon, is basically what we now are a low-code platform that is based on graph technology. And I will take you to a number of cases that we are, let's say, that we are dealing with, and also tell you a little bit about, okay, what are the elements that we use to create those what we call graphy applications. So I'll do, let's say, if you really have urgent questions, let's say, just interrupt me if things are not clear. I'm flexible enough to be able to handle that. If I know that I will address that question later on, I will ask you to wait a little bit. But basically, please interrupt me if things are not clear. Michael, James, I know that this is being recorded, right? Yes.
Yes.
Okay. Good. Okay. So basically, and this is perhaps a little bit familiar for you, that currently connected data is really, it's very big. Yeah, and we have many organizations that go through all kinds of digital transformation, and they want to start linking all their data that is now in silos into bigger structures, mainly, let's say, triple sets or graphs. And in this example, we do a lot of stuff in supply chain where you have a product that has component or subcomponents, and typically these bills of material are not symmetrical. Yeah, they have layers of different depth. Imagine a bill of material of an airplane that is about 2 to 4 million parts, with all of that linked to materials and stuff like that. Also, in these supply chain and manufacturing cases, you have to deal with machines, and machines need persons to operate it. These persons need to require certain skills. And these components, they are supplied by a given supplier, which may or may not be on a sanction list. And then to get the product from the supplier to the factory, you need to have warehouses, you need to have transporters and stuff like that. And those machines, they are maintained and they keep logs in different versions, and also they have manuals versions, and there also the persons need to have certain skills. And all these persons, they also are organized in departments, and then there is still a lot more. But where, let's say, now lots of these different systems are managed in silos, basically what you need is something like this, because this is really the reality of everything being connected. And I think we all know that the traditional relational databases, which are really good for rectangular stuff, they are not designed to get real-time information out of these kind of systems, especially not when these models are evolving. Of course, I think I read on your website a lot of interesting stuff about triples and graphs, and these models are a lot more extensible when the need arises. And of course, we have these connected data in many sectors: manufacturing, supply, social network, financial transactions. Also, you see more and more digital twins, drug discovery, master data mines, and of course also let's say as a source of information for language models and AI, machine learning, etc. So what we think, and I think that's not very new for you, I think, is that that this technology is really helping to, let's say, to get better insights and to create more value out of the data. Now this is about data, but let's also talk about applications, because what often happens, on the left side you have a graph, which can be complex or not complex. Very often these graphs have millions or even billions of nodes, but basically what the user will interact with is something that looks as the pictures on the right. You need maps, you need charts, you need grids, you need forms, sometimes in different combinations. These have to be interactive, but in the middle there is this coding part, which is quite expensive, takes a lot of time, lots of stuff, and currently at this moment software engineers, and especially software engineers that have experience with graph or graph-like structures, are very scarce. So what we started to do, and well, basically I cannot even do it, and I want to go from left to right, without wanting to develop a lot of stuff. So we came up with something that is, let's say, like the part in the middle. It's very visual. It's functions that are connected to other functions and which are also graphs. So what we do, we have found a way to, let's say, to model applications as graphs, and also to run them from those graphs directly. So if you look at a function, and that this is a kind of meta model and it shows you the kind of entities and relations between entities that we use, 99% of applications, they consist of functions that trigger other functions. And then a function, we consider that as something quite generic. A function can be a form, a function can be a grid, a function can be a query, or a request or an API endpoint. And typically in a function you have hundreds of functions that are linked together. And these functions, when you look at a user interface, they can be grouped in dashboards. And on these dashboards you have shortcuts that trigger those functions, or in our case you also have start relationships that automatically fire a function whenever the dashboard is loaded. And when you have, let's say, these users, there are users and teams, and users can have access to dashboards, be it directly or through teams. And teams can be also, as you can see from the relationship, they can be a nested structure. Also non-symmetrical, but anyway, if there can be a path from a user to a dashboard, then that user can see that dashboard. And also we have permissions that you can also model as a graph. So you can create what we call permission nodes that describe a permission, and then a certain function requires a permission, or a dashboard requires a permission to be loaded. And users or teams can have these, but they are allowed to do whatever is described in the permission node. And so, with really a very simple model with 1, 2, 3, 4, 5 different entity types, we found that we can really create quite complex applications. And in a very easy way, in the sense that someone who has the, let's say, analytical capacities, but not necessarily has the programming skills, can build stuff. And I will show you later a number of examples of things that you could build with this. Any questions so far, or is it clear? Yeah, I know from the OZEP side there are a number of people who can think in a very abstract way, so that's always good.
Yeah.
Okay, so we have basically what, let's say, the top left corner, the functions and triggers, that are basically, it's 99% of the application. It's a very simple structure. It's a very simple pattern. And you will, I will show you more about that. So for the functions, for instance, we have function types, grids, maps, charts, also network visualizations, forms, and trees that are the hierarchical structures. There are also function types that do not have a visual component, like queries, I/O functions, etc. And there are a number of functions that are basically oriented to integration with third-party systems. So that's a request. It's an API request to a third-party API endpoint, but also Graphileon can serve itself as an API endpoint. And whether the triggers, so the triggers depend on the type of function. So there are some generic types, function executed, function updated, and error. But for instance, a query can have a success trigger. So that trigger fires when the query is executed. We can, for a network, you can, for instance, have a node double click, but you also have node click, relation double click, all that kind of things. For a map, for instance, you can click on a marker that triggers an event. So these are all specific sets of trigger types that can be, let's say, that identify the trigger, and they have a payload, and that is, well, it's immensely powerful. Okay, I want to, just to illustrate this, I have a small example, and that also shows you a little bit what the user interface of Graphileon looks like. This is basically, you can run on Graphileon.app. You can register for at this moment for a free account. It's our cloud beta version, and you can run it currently on Neo4j and the memgraph, which are two of the, let's say, the graph databases that are really a little bit ahead of the curve. So when I log on, I have a number of dashboards, but I will go to this dashboard called question-driven Graph Explorer. And there you can see that there are different components. So here I have a grid. Here also I have a grid, but it doesn't have any data. This component here is what we call a network visualization. And also this one here is also a grid that is interactive. And I use this example with the movie database. That's a database that is quite often used to demonstrate the capabilities of a graph. So here I have my entity types. If I select an entity type, so movie, I can say, okay, take this one to the graph. I can just double click here. So this one, in this case, I have a double click event that puts it here. And as you will see here, there are some questions, and they are context sensitive. So if I click on this node, it says, okay, who acted in this movie? And then I can have my answers over here, and I can add them to the graph. Now, if I would select a person, then here the questions change. And if I have multiple nodes, then in which movies did these actors together? Okay, there is only one, which is Apollo 13. So this is part of the UI, but it really becomes interesting when there is of course this this question-driven Graph Explorer. It depends on a schema. So we have a JSON schema in here that has, okay, it has movie entities and it had person entities, and for the movie I have my properties, and for the person I also have my properties and the different relationships that can exist. So this is basically the schema that you can use. This schema being available, it becomes very interesting when you don't want to write your Cypher queries yourself, but you want to use a tool like ChatGPT. So this system now allows to send a human language query to ChatGPT together with the schema in the prompt, and ChatGPT returns this statement. So this is a statement that is automatically generated by ChatGPT, and then it is back and it is run directly on the database. So without providing any data to ChatGPT, but only the schema and the question, this is what GPT is capable of. And if I want to say return the age of the actors at release date, then it also does that. Yeah. You can also oh, okay. Yeah, sometimes. Okay, yeah, it creates your graph. So with this, the combination of different, let's say, types of technology and a platform like ours, this becomes very easy. And if you now want to see what kind of components we use to have this ask something feature, Let me duplicate this one. We have the possibility to create diagrams, and here I have an ask. So this is basically this is the entire application. So I have here, this is what we call a dashboard node. So that represents the dashboard. I have an input form, a view. So this is basically a form. This, when the form is used, then it takes let's say it generates the prompt for ChatGPT. In this case, it's GPT-3.5 with some additional instructions. So I don't want to use the wildcard when it returns the query, etc. And that query that goes to the API endpoint of OpenAI. And then let's say the query comes back, and this is the query node, which has no cipher because it's dynamic, it's generated, and then it outputs to, this would be the grid, and this would be the network visualization. So here, with only a very, very few components, you can build this kind of functionality. Yeah, so that is basically what we do. Are you in for another example? There are many things that you can build, and perhaps it's a little bit. Okay, then let me have this one. Okay, I have here a number of demos. So from here also, I'm a power user. I have many dashboards in this case, but there is here on this dashboard there is a shortcut which is called charts, and when I run that, okay, basically it triggers a query, and that query when it's successful, it outputs to both a chart and a grid. And then when I have a grid, I can click on a row. These are now and then they are, as you can see, they are dynamic. This is a completely different example, but it's also quite simple. I have a dashboard. I have a shortcut here, and that has an icon, and it has a title. So that's bar chart, and this one translates into this one. There's a cipher query here. By the way, we mostly work with our customers mostly work with labeled property graphs, but this one can also run. We can do RDF Sparkle Star also, but it's a little bit more complex, and we can perhaps spend some time discussing what let's say for this specific use case, having this kind of graphy application, what would be the best, let's say, the best way to go, whether RDF Star is, for instance, really offering advantages, or whether it could be better a more structured approach using labeled property graphs. So here you have, for instance, I was talking about the triggers. So when this data is output to this grid, then when I execute this row click trigger, then this trigger is then the parameter for my next query, and that outputs to those 3 charts. So this is another example. I'll do just one more, and then I think it would be good to have some questions from you guys. Something a little bit more. A lot of people now are talking about knowledge graphs, and knowledge graphs are typically these kind of structures that you do not navigate in a linear way. Sometimes you want to use, this is a tree component, you want to be able to navigate it like this, or you want to go through previous and next. So I can go to safety policy, I can go back to introduction, I can abbreviations, I can navigate it like this. Sometimes you want to use a full text search, please. Okay. You want to, but sometimes also you want to look at the different pages in their context. So here I have legislation. I can navigate even using this. And if I want to create a new page, let's call this page semantic arts. And I have a word. What is today's word? Someone has an interesting word for today? Well, then I'll put in Wimbledon, which it was. Wimbledon is a child, let's say, put it a child of compliance. I can have a previous page. I can have a next page. I can say, okay, I can have some links in here. And of course, I can have some Lipson, and I put in, I think this was one of the persons who was playing today. So you can add this this page and immediately. So it is now here. It is linked to this page immediately. I can show it here in the context, etc. And I think it is indexed also immediately. Yeah, it's indexed immediately. So this kind of application, which is very non-linear, by staying, let's say, within the context of the entity types that we have, even this application, including the new page, is quite simple in the sense that, okay, this is the entire application. So there are about, we call these Graphileon functions. So there are about 20 functions that link to each other. And that make up an application like this. So this application can be, apart from the content, of course, it can be built in let's say, in a day by someone who is familiar with, let's say, with this kind of very visual building. The advantage, of course, and we are, let's say, we consider ourselves, let's say, somewhere between startup and scale up, and we have, of course, still lots of items on our roadmap, and one of those is to fully use the capabilities of graph algorithms, not just to analyze the data, but also to analyze the use of the application. Because since everything is stored, we can exactly monitor or log which triggers are fired more often than others. So you can say, where is the focus on the application? Is the application is this part being used? Is this part being used? And if you have that information, you can create heat maps of an application. That's one thing. You can preload stuff in application, because everything persists on database, but when a function definition is loaded into memory, it can be cached. But then you can, of course, very easily see, okay, which part of my application should I optimize? Another thing is, of course, is if I want to update this function, I can immediately see, okay, where are my dependencies? So especially for larger applications, so this is an application of about 20, 30 nodes. Our biggest applications are about 1,200 nodes. So it's very typically a small graph, but it's very quite connected. It's not easy to see always if you do maintenance on application with how things could impact. Yeah, I can stop here for a moment. I can talk a little bit about how we deal with permissions, because permissions is also something that is, especially in a graphy structure, is not always easy. But I prefer to, if there are any questions, I could take them now.
There was a quick question in the chat about utilizing RDF schema or Sparkle.
Yeah. Oh, I didn't see the chat. I should open that. Sorry.
That's okay. Yeah, I can keep an eye on it too.
Yeah. We let's say we have, and that is still a little bit in beta. We have worked with EnzoGraph, which is probably a product that you're familiar with.
Yep.
What for us is a challenge for using RDF is that if you write, so in principle it is possible, especially to query the data. Building applications is a little bit different, especially if you have a schema, and our functions require often that users add additional properties, so they do not necessarily adhere to a schema. They have some minimum set of properties, but they can always be extended. One of the challenges that we have with Sparkle is that it's not always clear when you retrieve a set of triples if you have the complete structure. Especially, let's say, so that's also why products like EnzoGraph, they have these special functions, edge and vertex, that allow you to have better certainty that you have all the triples collected. Because, for instance, if you have a select and you do a limit x, you still can miss some crucial triples. And of course, with an LPG, where all the node information, all the node properties are part of the same structure, you don't run that risk. So that's and also you have to, when we are using RDF, you have to specify in the returns what columns in your result are part of which structure, and that comes automatically when you have graph structures directly. So we have and when it's let's say, so the answer, the short answer to can I use RDF schema, use Sparkle, the answer is yes. But mainly for the data part, not for the application part. Drag and drop style programming is appealing for the first few weeks. Yeah, we can. Let's say what we do not do to the second question. Drag and drop style programming is appealing for the first few weeks. Textual programming is more efficient. Well, we can, first of all, the functions, you can create your own functions, so that have perhaps a larger degree of liberty, a degree of freedom to do that. And of course, all these functions, we sometimes no, this is perhaps not a good example, but for instance, this is a tree view component. So basically, we have wrapped a lot of functionality in here. So this for an entire tree view component with all the behavior for expanding, clicking, and stuff like that is all in the function. So you don't need to do that. But there is, of course, you can have your JSON as well. So that is what we often do. But linking, we currently do not have a mechanism to, let's say, programmatically add triggers, for instance. What we do have, though, is that we can export, for instance, this entire configuration. I can export it to JSON, which gives the entire structure, including all the properties, the query statements, etc., and that you can or put in a Git-like structure or use it to create a complete copy of the application. So there are multiple ways to do that. but and also something that other low-code platforms sometimes do is that they write code, and we don't write. Our software doesn't write code; it is executing directly as a function. So it's not that you can, let's say, you can create a basic structure in, for instance, in JavaScript or TypeScript, and then you can continue working on that in, let's say, giving it to a number of developers to refine the code or perhaps to optimize the code. That's not what we do. Are there any other questions at the moment? Then I can perhaps explain a little bit what we do with in terms of permissions, because we also have modeled our permissions in a very well. I showed it a little bit on the in the slides. We have functions that require permission, and we have users directly or through teams that are allowed to do something. And basically, these permissions, they have to be, very often they have to be dynamic. And we can do both static and dynamic. So for instance, we can say here we have, this is a grid, and when you click on a grid, you can get a quote. But that, let's say, if this permission exists, so which is quite static, this demo person has to have this permission to be able to run this query. So that is one way of, let's say, of creating granular permissions. If you go a little bit more advanced, we can say, okay, we have an expression-based permission. So basically, you pass a parameter to an expression, and then you can, for instance, formulate things like, okay, I can only create a quote if my price is under than 10,000. So if I have to do more than 10, the price is higher, I cannot do it. And the third one, and that is really the most powerful one, and you combine very often data and application parts, is that you dynamically evaluate your data store to see whether someone has a permission or not. So in this case, if this pattern, let's say if the quote is in the same query in the same language as one of the languages that is spoken by the user, he can create it. If not, he cannot create it. And that is extremely powerful. For instance, you can have situations that someone can only create. Well, let's have some fantasy example. Create a quote for a product that is produced in the country where, well, for instance, the wife of the CEO lives. You know, you can create those dynamic things, and which is very powerful. And especially in our case, where we don't deal a lot with federated data. For instance, that is typically an example where you would be more use RDF. This corresponds very well. It serves very well for our case. Not necessarily that the graphs are small, but they are hardly ever federated.
Mm-hmm. Now, this is impressive. Are these permissions reusable? So once you invent this idea that you can only read this if you read Dutch or something, but yeah. Right now this was in a particular row in a particular grid. Is there some way to say this applies in a lot bigger context?
Yeah, because you could have, let's say, this cipher statement, yeah, it's stored in the permission. So if you have another situation where you have another query that requires the same permission, you say also, okay, that other node also function requires the same permission. So you can reuse it.
Oh, it has an ID or something.
Yeah, it
Yeah.
has an ID. Yeah, and that
Okay.
is of course something
Yeah.
that I personally, well, it helps us a lot that, for instance, in a labeled property graph, everything has an ID. You know, whether it's a vertex or an edge. Of course, you can get close to that with RDF star, of course, because we very often have relationships of the same type, so they are from the type trigger between the same nodes. So you have multiple relationships of the same type, and so, for instance, our queries, our triggers can be they can be conditional as well. So let me. I have one example here. I think there. Okay, yeah, I have here something that is called, where is it? Conditions. Yeah. So if you have, what's your age? It says, okay, you cannot see the whiskey list. Yeah. If you do the same for 23, it gives you the whiskey list. Yeah. And I think if it's 21, then also it gives you the list with the whiskeys. Yeah. So basically, if you look at the logic behind this one, conditions. So I have something that is called conditions that takes a prompt, and then based on the same prompt, so you can evaluate under the function. Okay, if this is true, it goes this way. Yeah, if this is true, it goes the other way. So you can have, depending on this, but you can have situations where you have, okay, you have multiple, so you can have multiple triggers between the same nodes, and that is, of course, it's hard to do in RDF because there your
Right.
So there you need you really need RDF star, but even then it's not always obvious how to do it. Yeah. So there are some advantages to LPG for the use cases that we are dealing with.
I'm on your website checking out pricing. I only partially understand it. So it's priced based on Graphileons. Is that how many icons, how many functions you have?
Yeah, the idea, let me explain that. And that's, of course, it's a question that we got. So we looked at this application, right? So this is this knowledge graph, and I'll show you the diagram again. Okay, so our thinking is that, okay, whether you have a small number of Graphileons, and Graphileons can be functions, either functions or users. So you can have an application with 2,000 users who are using quite a simple application. Or you can have an application of about 500 nodes and less users. So in both cases, that represents value for the company who uses it. Yeah. So for instance, for our Graphileon 256, yeah, which is 256 node Graphileons. So you can have an application from 50 functions that is used by 206 people.
Oh, you add them. Okay.
We add them.
Okay.
Yeah.
Yeah. Okay.
It's
okay.
not. No, we do not multiply them.
Yeah,
no.
That's right. That's where I thought you were going.
No. Yeah.
Okay.
So
this one we're looking at here is 20 or 30, right?
Yeah, 20 or 30 nodes. Yeah, each function, whether it's a UI function or a backend function.
Yeah.
So that is what we do for our, let's say, for the on-prem situations. we are now, as I said, the Graphileon.app is in beta, and there we are considering to have a metric that is more related to, let's say, the number of times triggers are executed. So that represents more the use of the function, the use of the application. Yeah, so you have a minimum amount of trigger executions. Basically, it's very similar to what you sometimes have if you have subscribed to the use of an API. You have each API call is costing you so many credits or something like that. So, and since we can, of course, since we have these triggers, we can exactly monitor when they are executed, and then especially when they go to the backend, because a lot of stuff happens also in the front end. That is, of course, not something that we can or want to measure, but that is something that we are currently, let's say, thinking about how we should do it. But that would be let's say the billing model for the cloud version. What is perhaps important to say is that, you know, I'm here now running a single instance of Graphileon, and as you see, this of course, this application is also a graph. And you do not want to mix these nodes and nodes and edges. You don't want to mix them with your business data, right? Because if you start applying graph algorithms, shortest path, etc., you don't want this to be involved. So what we basically always have, and let me first go to the simple example, our cloud. So you have, in this case, these days are running on Neo4j, a community version. So we have one instance of Neo4j that only contains the application and the user nodes. So it is not invasive. We can even, if you would have another store somewhere in Aura, or you could easily connect Graphileon to it, and without, let's say, you just read from that. But you can, what in this case, and of course I'm a power user, that's why you see I'm running here this instance, this single instance of Graphileon. I'm running it against all these databases at the same time, which is various vendors, DataStax, EnsoGraph, Neo4j. And what you can even do is to run a query in different languages. Let's say you can do to Neptune. We also do Neptune, so you have Gremlin, Sparkle, and Cypher. Fire them at the same time, collect the data, merge the data, and then display them. So that is something that is possible, because you only need one instance of Graphileon to manage all these data. And in the different licenses, you can see that some depends a little bit on the license. So it tells you what's so how many applications, how many data stores you can have, you know. So that normally it's 3, but then for the other editions it's not limited. So you can even link a couple of hundred Neo4j instances to it. For us, that's not a metric for us, because we only have a very small graph. Graphileon sits apart. And if you want to run something very heavy, of course, most of the workload is in the graph engine anyway. Yeah. Does that answer your question, Dave?
Yeah, pretty much. Although, leave this up where it says in the blue, dashboard no limit, user no limit. I mean, the limit is 256, right?
Yeah, it says. It should be in the Graphileons. Yeah, it's always within the 256. Yes, this is of course.
Okay. Yeah.
But normally, let's say when you start a default installation from Graphileon, you know, it comes with a standard definition, and that is what we call the standard configuration, which is also about 40 or 50 nodes. They are not counted in the let's say they are not included in the count.
Okay.
Yeah. So that's I think you can say that.
Yeah.
Yeah, it says core nodes, so they are not included, but you can reuse them in other applications. Yeah.
Yep.
There was one question in the chat on the roadmap. Any additional thoughts on kind of where things are heading you haven't already shared?
Well, there are, yeah, we are in release. So for instance, we are now moving into the I think it should be here. So we are now moving into the building information space.
Mm-hmm.
Interesting. Okay. So of course, this is also a graph. You know, you have the IFC files. I'm not sure how many of you are familiar with the IFC format, but of course, this is also a nested structure, and it also comes with all the interactivity. So for instance, you can say, okay, give me only the stair parts of this one.
Nice.
Yeah, and that of course, when this is related to information on companies, materials, etc., of course, it becomes very, very interesting. So this is a 3D viewer that we are about to release in our next version. Will be come out. Then there is another view which is new. Come on. Where do I see this? Interesting. I hope I was able to show you something. No, I can't. I thought I had access to this, but that's a 3D viewer. We have so for instance, we have this is, let's say, this is a picture of, which is also a graph of the drug development process, and which has been interactive in the sense that you can now use this also as an entry point for data for surveys. And the view that I wanted to show you was something that is a 3D version of it. So if you make this a 3D, and then you can have counts on top of these things. But I thought I had that, but it's why is it not available? Oh yes, I know. Yeah. Okay, I have it. Yeah.
Oh, neat.
See this kind of thing that you can do then, and then you can click on here, and then there should be data. Yeah. Okay. So you have here the data that can these are also interactive. So that is also something that is new. If you want to have, if you have a complex process and you want to say, okay, where is my workload? This is also a nice way to visualize that.
Yep. Yeah,
And
very nice.
you can have different metrics.
Yep.
Yeah. So those are new for the next version, which is to, I think it's I think we send already out another newsletter that reminds me of something that so often you want to show nodes that are quite rich in terms of content, and what you in that case want to, let's say, you where is it? Feature, I think it's a feature demo.
While you're looking for that, we're coming right to the end of the hour. I just went on your web. Go ahead, finish your thought.
No, go ahead.
I just went on your website, looked at your team. It looks like there's only 4 or 5 developers. Did 4 or 5 people build all this?
Yeah.
Wow.
Yeah.
That's impressive.
Well, it took us some time. And
yeah.
Let's say if you stick to very simple concepts, because I consider us as a, let's say I didn't write not a single line of code. I can read code, but I always tell them, don't let me touch a server because I will break it.
Mm-hmm.
But if the concept is simple, let's say if you really stick to the concept of a function that triggers a function, that's your key element. And then that's basically is a simple trick. And if you know how to execute that trick very rapidly and consistently, then it opens enormous possibility. It's like, we consider ourselves the digital Lego building blocks.
Mm-hmm.
Yeah. And every time sometimes, you have these use cases where you need a piece of Harry Potter Lego. Yeah. As long as you make sure that one has a part of it that fits on the other 40 or 50 functions. Yeah. You can gradually grow the number of different Lego building blocks that you have. And so that is what we do. The concept is simple. So yeah, that I think allows us to, and it also makes it maintainable, because all the demos that I've showed you today, they are built from a single source code. Yeah, so it's all and it's the more complex applications you build. Of course, sometimes it's not no code, but it's low code from something. What you sometimes may need to do is to tweak some JavaScript objects, but that's basically Lodash and pure JavaScript that you can do on the triggers. But for this, I can build all these applications, and without having coding skills. So yeah.
Excellent. All right. Well, I think we're at time.
Yeah, that's very impressive. Thank you, Tom.
Well, thank you guys for attending.
Do you have a U.S. presence?
Well, no, because the number of people that we have, we don't have a U.S. presence. No, and basically in terms of partnerships, let's say any database technology, but I think especially the ones, if you go into RDF or LPG, there's a huge variety of use cases where it can be useful.
Sure.
I come from agriculture international development, so we do not master all the domains. For instance, for this BIM, this IFC building information management, we work with, let's say, often a partner in architecture. Yeah, we have a customer in the United States that is specialized in, it's a company called Power Central. They are into food processing and manufacturing and packaging, sorry. So that's into we built together with them on their specs a system, let's say a kind of ERP for and planning board for all these production lines. We also have a partnership with a company on the west coast called Graphileon. They are using Graphileon to map complex SAP and SAP enterprise mapping, because SAP
is that John Conte?
You know the guy. You know the
Never
guy.
heard of him. Never heard of him.
Now tell me. You have to tell me.
Yeah. Yeah.
But he has done everything with Graphileon.
Oh, really? I didn't know. He didn't tell us that. I mean, I've seen all his stuff. I didn't realize he was using your stuff.
Well, it's Graphileon inside.
Yeah. Yeah. That's good.
Okay. Well, I think it's quite impressive. Although I am not
absolutely. Yeah.
specialist. But he has learned himself the Graphileon skills, and he has built some amazing stuff.
Yeah. Yeah, absolutely.
Yeah. And so that's the kind of partnership that we look for, since we are very horizontal. We are looking for partnerships with people, domain experts.
Yeah. Very cool. Okay, well, we got to run. That was very impressive, Tom. Thank you.
Thank you, guys, again. James, also thank you for the opportunity.
Yep. Yeah, thanks for joining us, and I'll send out the recording here to everybody and be in touch.
Okay, I can publish the recording, right? It's public.
Yes. Yep, absolutely.
Okay. Well, then just send me the link if you put it on YouTube.
Yep, will do. It will be up later today, and I will send it on over.
Okay. Thank you very much.
All right. Thanks, everybody.
Okay. Thank you. Bye.
Thank you very much.